This video will cover the second page of notes on the topic of rational functions. Let's start with example number 1 that states our job is to graph f of x is equal to 2 over x plus 1. One of the things I want to remind you here is that we can write this as 2 over 1 times 1 over x plus 1. Remember, we would multiply tops times top, and that's how we would get a 2, and bottom times bottom, that's how we get x plus 1. So we can see our parent function is 1 over x, so we know that it's going to look something like this. We have a plus 1 on the inside, which means we're going to go to the left 1, and we also have a multiplier of 2, so we're going to multiply those y values times 2. So what we do is we start over here at 0, 0. We're going to go 1 to the left, and you see how I put this green vertical asymptote right here at x is equal to -1. And then we did not move it up and down, so I put a blue horizontal line to show that that's going to be our axes like this. So we moved it, we got a vertical asymptote and a horizontal asymptote. From the new origin, we will go over 1, up 1, and this is where our point would be. I'm going to put it in red, that this is where it would be if it did not if the multiplier was just 1. But because we have a multiplier of 2, we're going to go over 1 and up 2, and that's why you see this point is the one being graphed. And we would do the same thing down here. We go over 1 and down 2 because of the multiplier. From there, I just went straight towards my asymptotes without touching them. I do that for the horizontal asymptote, and I do that for the vertical asymptote. We were able to graph this without actually going through a lot of details about asymptotes and graphing. But what we can do is we can look at our denominator and ask ourselves, when is it undefined? It's going to be undefined if x plus 1 is equal to 0. So that's what we're asking here. Like f of x is undefined when x is equal to -1. So I just solved this linear equation, and that will give me my vertical asymptote. We already know our parent function, and we graphed it. From the graph, we can see our domain and our range. Notice that the x values are everything except for when x is equal to -1. That's what our domain tells us. And our range will be all those y values, with negative, positive, but it will not equal to 0, and therefore we will have our range to be this. Let's try example number 2. Our job is to graph f of x, where f of x is equal to x plus 2 over x plus 1. Well, that's kind of different from what we've seen in the past, but what we can do is use synthetic division. Notice I'm going to have a 1 and a 2 for our synthetic division here, and then I'm going to put in my box, I'm going to put -1, bring down my 1, and then I'm going to multiply -1 times 1 is a -1. I add, I get a positive 1. So since this was an x, I go down x to the 1 power, I go down to x to the 0 power, which is a constant, and then we would have the 1 over x plus 1. So we put our remainder over our divisor. So now this is what f of x looks like. So that's something we can do. From here, we know that we went to the left 1, and we also went up 1. So we're going to use that for our asymptotes in a minute. So to find vertical asymptotes, what we're asking ourselves is, when is f of x undefined? It's undefined when the denominator is equal to 0. So I let x plus 1 equal to 0 and solved, and that's how I got x is equal to -1 is my vertical asymptote. So how do I do my horizontal asymptote? We can take a look at in behaviors of our graph. So let's first do some graphing. So we have learned that what we want to do is I'm going to get my green vertical asymptote, which is left 1. So I went to the left 1, and you can see my green vertical asymptote right here. And then we went up 1. I'm going to put that in blue. You can see that blue horizontal asymptote because that's where we moved it. And then when we graph it, we don't have a multiplier, so we would literally just go from our new origin, we would go over 1, up 1. That's where I'm getting that point. Likewise, I would go to the left 1 and down 1 because we know our parent function is our reciprocal. So then from this point, I get close to my asymptotes. I get close to my asymptotes. Same thing for the bottom branch here. And that's how I finish graphing it. And we can look at our end behaviors. Remember, our end behaviors ask as x goes to negative infinity, what are the y values doing? Well, the y values are actually getting closer and closer to 1, in this case from below. And then we would do the same thing on the other side. As x goes to positive infinity, the y values are getting closer and closer to 1, and in this case from above. But remember, this part right here is what's telling me what my horizontal asymptote should be in our graph. So this part down here in red, this part in red will tell us our vertical asymptotes, whereas this part in blue will tell us our horizontal asymptotes. And that concludes this video.